Intro. Welcome back to our channel. Today, we're diving deep into the world of artificial intelligence and machine learning, specifically focusing on how to create a production-ready AI workflow. If you're looking to leverage AI in your projects, understanding the entire process from data ingestion to model deployment, along with integrating continuous integration and continuous deployment or CI/CD practices, is essential. Whether you're a data scientist, machine learning engineer, or simply an enthusiast, this video will guide you through each step of establishing a robust AI workflow that can scale and adapt to your needs. So grab a notebook, and let's get started. Section 1: Understanding the AI workflow. Before we jump into the nitty-gritty, let's briefly outline the key stages of a typical AI workflow. The process usually consists of several interconnected phases: data ingestion, data preprocessing, feature engineering, model training, model evaluation, and finally, model deployment. Each of these stages plays a critical role in ensuring that your AI solution is not only effective but also sustainable and efficient in a production environment. It's important to recognize that this is not a linear process. Iterations and improvements will be an ongoing part of the lifecycle. Section 2: Data Ingestion. Now, let's begin with the first step: data ingestion. This is where the journey starts, as the quality and quantity of the data you gather will directly impact the performance of your AI model. Data can come from various sources, including databases, APIs, flat files, or real-time streams. When it comes to data ingestion, one of the primary considerations is to ensure that the data is both relevant and high quality. You'll want to implement automated data collection pipelines that can regularly fetch and update data. Tools like Apache Kafka or Apache NiFi can be beneficial for this purpose. These tools allow for efficient handling of large data volumes and can help in creating a real-time data ingestion pipeline. It's also crucial to establish data validation checks during this stage. You may want to implement tests that ensure the data meets specific criteria, such as schema validation, data type checks, and detecting missing or anomalous values. By doing so, you're setting the foundation for the rest of your workflow. Section 3: Data Preprocessing. Once your data is ingested, the next step is data preprocessing. This stage involves cleaning the data, transforming it, and making it suitable for model training. Data preprocessing can include a range of activities, including handling missing values, removing duplicates, normalizing or standardizing data, and encoding categorical variables. One effective approach to preprocessing is to automate this process using tools and frameworks like Apache Spark or Pandas in Python. These tools can help you handle large datasets efficiently and apply transformations with ease. You can even create data pipelines using tools like Apache Airflow to orchestrate the entire preprocessing workflow. Remember, the goal here is to ensure that the data fed into your model is of the highest quality. This phase can significantly affect the model's accuracy and performance, so take your time and ensure no stone is left unturned. Section 4: Feature Engineering. After preprocessing, we move to feature engineering. This step is crucial as it directly influences the model's ability to learn and make accurate predictions. Feature engineering involves selecting, modifying, or creating new features from the existing data to improve model performance. To do this effectively, you should have a good understanding of the domain you're working in. Collaborating with domain experts can provide valuable insights into which features might be most impactful. Additionally, consider using techniques like dimensionality reduction, such as PCA, principal component analysis, if you have high-dimensional data. Automating feature engineering can be challenging, but platforms like feature tools or even custom scripts can help streamline the process. Keep in mind that the ultimate goal is to create features that contribute to model performance while avoiding overfitting. Section 5: Model Training. Next up is model training. This is where the magic happens. You take your prepared dataset and pass it to machine learning algorithms to generate a predictive model. It's vital to select the right algorithm based on the problem you are solving, be it classification, regression, or clustering. During this stage, it's also essential to implement hyperparameter tuning to optimize your model. Techniques like grid search or random search can help you determine the best parameters for your model. You could also leverage libraries like Optuna or HyperOpt for more advanced optimization techniques. Another important aspect of model training is scalability. You want to ensure that your training process can handle increasing amounts of data without significant performance degradation. This can involve using cloud computing resources or distributed machine learning frameworks like TensorFlow or PyTorch, which allow you to leverage GPUs for faster training. Section 6, Model Evaluation. Once your model is trained, it's time for evaluation. This step will help you assess how well your model performs and whether it meets the desired performance metrics. You should use a separate validation dataset that the model hasn't seen before to gauge its real-world effectiveness. Common metrics for evaluation include accuracy, precision, recall, F1 score, and ROAUC, depending on the type of problem you are solving. It's crucial to analyze these metrics carefully and make necessary adjustments to improve your model. Moreover, consider implementing cross-validation to ensure that your model generalizes well across different datasets. This technique involves splitting your data into multiple subsets, training the model on some of them while validating it on others. This approach gives you a more robust measure of model performance. Section 7, Model Deployment. Now that you have a well-trained and evaluated model, it's time for deployment. This is often the most exciting and critical phase, as it involves putting your model into production so that it can deliver value to users. When deploying a model, you have several options. You can deploy it as a batch job, integrate it into a web application, or even expose it through an API. Popular tools for deployment include Docker, which allows you to containerize your application, and Kubernetes, which can orchestrate your containers at scale. It's also important to have monitoring and logging mechanisms in place post-deployment. By tracking performance metrics and user interactions, you can ensure that the model behaves as expected in the real world. Tools like Prometheus, Grafana, or ELK Stack can be invaluable for monitoring deployed models. Section 8, CI/CD Integration. With the deployment process underway, the next step is integrating continuous integration and continuous deployment practices into your AI workflow. CI/CD is essential for automating the testing and deployment of your model updates, ensuring that they can be rolled out reliably and efficiently. In a CI/CD pipeline, every time you make changes to your codebase or update your model, automated tests are run to ensure everything is functioning correctly. This can include unit tests, integration tests, and even performance tests for your model. You can use tools like Jenkins, GitLab CI/CD, or CircleCI to set up your CI/CD pipeline. The key is to create an automated process that triggers these tests every time you push new code, allowing for quick feedback and minimizing the risk of introducing bugs or issues. Moreover, consider implementing model versioning to track changes to your models over time. Tools like DVC or MLflow can help manage and version your datasets, models, and experiments, ensuring that you can reproduce results and roll back if necessary. Section 9, Maintenance and Iteration. Finally, let's discuss maintenance and iteration. An AI model is not a set-it-and-forget-it solution. Over time, as new data comes in, your model may start to drift and perform poorly. Regularly monitoring your model's performance and retraining it with fresh data is crucial. Implement a feedback loop where you can take new data from the production environment and use it to improve your model continuously. This iterative process is vital for ensuring that your AI solutions remain relevant and effective in a rapidly changing environment. Additionally, stay updated with the latest advancements in AI and machine learning. Technologies and methodologies evolve quickly, and keeping abreast of new tools, techniques, and best practices will help you maintain a cutting-edge AI workflow. Conclusion. And there you have it. We've covered the complete journey of creating a production-ready AI workflow, from data ingestion to model deployment and the integration of CI/CD practices. Each stage is critical in developing a robust AI solution that can deliver real value. We hope you found this video informative and valuable for your AI journey. Don't forget to like, subscribe, and hit the notification bell so you won't miss any of our future content. If you have any questions or topics you'd like us to cover next, feel free to leave them in the comments below. Thanks for watching, and see you in the next video.